Thanks everyone for joining back. It is my great pleasure to introduce Professor B.N. Goswami, a renowned physicist and meteorologist whose groundbreaking contributions have advanced our understanding of weather and climate systems. Professor Goswami is currently a SERB Distinguished Fellow and Professor of Practice at Cotton University. One of the India's most distinguished climate scientists, his beginnings are in a rural village in Assam. After completing his BSc from Cotton College, Guwahati, and MSc in Physics from Guwahati University in 1971, Professor Goswami earned his PhD in plasma physics from the Physical Research Laboratory in Ahmedabad. It was during his doctoral studies that he began focusing on weather and climate processes, laying the foundation for his groundbreaking career. He honed his expertise during his postdoctoral work at MIT with Professor Jules Charnay, who is considered the father of modern meteorology. He further expanded his contributions at NASA's Goddard Space Flight Center, where he worked on the emerging field of monsoon modeling. Returning to India in 1983, Professor Goswami joined the Indian Institute of Science, Bangalore, where he served until 2006. During his tenure, he rose to become a professor and a chair of the Center for Atmospheric and Oceanic Sciences. He made several fundamental contributions to understanding the variability and predictability of the Indian monsoon on interseasonal and multi-decadal timescales. As the director of the Indian Institute of Tropical Meteorology in Pune from 2006 to 2014, he led the Indian Monsoon Mission, significantly improving the skill of weather and climate forecasting in the country. His work bridged a 30-year gap, bridging Indian prediction capabilities on par with global standards. With over 200 publications in high-impact journals, including Nature and Science, his research has garnered over 26,000 citations and an H-index of 67. His seminal papers on the Indian Ocean Dipole is among the most cited works from Indian institutions. Professor Goswami's numerous honors include the Shanti Swarup Bhatnagar Award, the K.R. Ramanathan Medal, and the Lifetime Achievement Award in Science and Technology from the Government of Assam. He's also a fellow of prestigious academies, including the World Academy of Sciences and numerous Indian ones. Today, we are fortunate to have Professor Goswami share his expertise and address the topic of research and development in the country. With that, I'll request Professor Goswami to start his presentation.
Thank you very much, Prakash. Thank you for inviting me. Of course, I must say that this is not a very new presentation that I am giving. It's something that I had presented earlier, but I have updated it. And you said that it is a new set of audience, and I hope that it will be useful. Good evening, everybody, and thanks for joining. So today I will basically talk about. I'm asked to talk about research and development in science and technology. What I understand that this topic contains three different sub-themes. One on your introduction of the constituents of research, then other on strengthening the research and its contributions, and the third is writing proposals and things like that. I thought I cannot do justice to all the three components, so I decided that I will talk basically on the main part, that is most of you probably know about the constituents of research and things like that. But I think what is important is how to strengthen our research contributions. So I think I will concentrate on that basically. My focus will be on this one theme. So what I would like to do is sort of address how research and development is important in the context of new education policy, NEP, and why do we need research and development in science and technology for innovation and technology innovation in higher education? So and then to do that, basically, we have to start with looking at what is the status of our research and development in science and technology in our country's universities. And then, of course, once we know that what is the status, then we have to see how we can improve this situation, how our university system can contribute to accelerating the science and technology innovations in the country. So I think with that kind of a plan, I will proceed. So finally, my focus also will be again on how to improve this current situation. So my perspective on how we can try to improve this situation, today's situation, I will focus on. So before I start the talk, I want to start with a bit of an acknowledgement, as Prakash mentioned, that I come from a very rural background with very little exposure and opportunity. But I must thank that over the during my career, I was fortunate to be associated with various different environments, enriching my experience in research and development in science and technology. First of all, I think I must acknowledge that my PhD in physical research laboratory uh, is a very premier institutions in the country, and I was fortunate there, and it helped me. And later on, my postdoc at MIT and NASA helped me to understand, learn about research ethics and research culture. Then my work at Indian Institute of Science, Bangalore, was another very premier institutions, and the academic environment there helped us to do how academic environment is very important in doing cutting edge basic research. I learned from there, and later on, as a head of the Indian Institute of Tropical Meteorology, I had the opportunity to do sort of translational research, taking the basic research that I learned in the Indian Institute of Science while I was at Indian Institute of Science, how that can be translated into useful applications in improving the weather and forecast model. So this gave me an opportunity to sort of not just do blue sky basic research, but translate the ideas of how what we learn from the basic research into applications. So these are all opportunities. I'm thankful, and whole my talk is based on basically these experiences, and these experiences give me some perspective on research and development. Finally, of course, I have been associated with the Cotton University for the last 7 years. During this time, I have been exposed to the state of affairs in research and development in the state universities, and this is also an experience. It's not a very pleasant experience, but this also gives me a perspective on what is the state of affairs in the state universities. So with that, so my talk will be basically based on my perspective and on research and development, learned from these experiences, and the examples will be from my field, which is climate science. But I think arguments are generic, and most of the examples available are also available in all of the other fields. So let us start with the research and development in the context of NEP. So why do we need, the research and development, be an important part of NEP? Because I think I think we have the research and development in the new education policy is required, because I think we need to transform our higher education systems from just degree giving institutions to institutions of learning, and empowering them for problem solving, so that the students, we have to create students which, the whole purpose of NEP should, I believe that the philosophy of NEP is to change this earlier education system, where people used to simply just learn information, but they were not taught how to think about solving problems. So I think this is what we have to do, change, and research and development is an important, going to be a very, very important part of that learning process. And therefore, to achieve this, we have to do that. Actually, we need to make students excited about it, and to get students involved in research and development, we have to get them excited about the topic, excited about the subject, and make them feel passionately about doing or finding the solution. So that is requires. Uh, so this is can be achieved through what I believe or can be considered education inspired by cutting edge research. So this is a philosophy that I think was promoted when starting our the ISAR systems, and that has worked pretty well, I think, in some of the ISARs. And this is where you do basically. You get students excited about the big science problems, big and how the big science problem can be solved by getting them involved into R&D projects while they are doing their even undergraduate studies, whether within the institutions and maybe also elsewhere. So you encourage them to do projects elsewhere as well as inside the institution. So if the institution has a lot of exciting research going on in different departments, different students can do projects, short-term projects within these different departments, and they get exposed. And when they get exposed, students will, generally will get excited, and that will then translate their interest and passion into the subject. So, so that I think is the philosophy behind this. And so now let us talk about the kind of a bit of history about need for science and technology innovations in higher education. As you know, over the past two centuries, science and technology has innovations and discoveries have sustained our exploding population from 1 billion in 1800s to about 8 billion today, or 8 billion plus. The life expectancy, not only it has sustained this population, but life expectancy has increased from 20 from about 25 years in those early days to about 70 years in India and some other places up to about 80 years today. And that is a remarkable achievement. It has happened due to a lot of science and technology innovations. Uh, but many of the science and technology, which was like a fiction in my own time, a lot of science fiction in my student days has now become reality. So within my lifetime, and that is the progress of science and technology innovations. So, for example, I remember this when I was a student, undergraduate student, we had this movie called science fiction movie called 2001 Space Odyssey, where Arthur Clarke in 1968, where there was this robot, the computer of the spaceship actually took over the spaceship, and how, sort of, that is time when actually computers were very primitive, and then this person thought that one day maybe the artificial intelligence will actually take over us, and today it is actually happening. And let us talk about all the artificial intelligence that the AI bots and ChatGPT and so on and so forth. All these can make now decisions which is as good as the human beings, and so therefore there is a danger of taking over although this is great progress, and a lot of opportunities it has brought in, but there is also danger of how this is going to change our lives. And in fact, that is also science fiction has thought about it. And then I read this other I read some fiction books in my free time. Then and this is a book by Dan Brown called Origin. I think some of you might have read it. Here he speculates how science and technology can actually take over us, and human species itself can change to a different species. And actually, probably it is happening almost. Look at how much we are involved today. Without the smartphone, our life cannot move. So it actually, big techs are taking over our lives, and therefore they're controlling it, and we are almost like a guinea pig in a lot of these contributions in the big tech. So the science and technology has in Mars is evolved tremendously, and it has changed our lives, and it has brought in a lot of benefits. Of course, together it is also bringing in a lot of potential perils. However, this industrial revolution itself, the industrial revolution, which brought all these the science and technology revolution innovations, have also brought created the monsters like the climate change, and which is leading to a sort of existential crisis for our humanity, and that we know. In addition to the exploding population, we are facing unprecedented, because of these we are facing because of these problems. So science and technology innovations have been great, but it is creating some side effects, which side effects are actually creating existential crisis for us in terms of food security, water security, health security, and all these requires now to solve these problems which we have created through innovations in science and technology. We have to create new innovations. Now that requires a new set of science and technology innovations, and that innovations have to be very fast now. Things are deteriorating so much, and so new innovations have to come out fast. For example, even to solve the climate change problem, we need a lot of new innovations which will produce green energy at a very fast rate, and that innovation is not happening at the rate that is required. So that is why we need to, the country, in every country, including India, has to create a lot of new innovations in the coming years, and that innovation very is going to come, and it has to come from all these education institutions, and that is why we need. And unfortunately, instead of that, we don't see that is happening very well in the whole world. In fact, the situation is not very encouraging. For example, in terms of climate change, which is where something that I know about. We need to drastically cut down the emissions. Without that, we cannot control this problem. But most countries are, instead of cutting down the carbon dioxide emissions, they are in fact supporting fossil fuel, subsidizing fossil fuel use, promoting fossil fuel. For example, United States itself, I think, annually subsidizes fossil fuel up to about $600 billion. But on the other hand, they are not putting enough energy, enough money into innovations of green energy. For example, the green energy innovations have declined globally. The percentage of green innovation in green energy innovations, green innovations, have declined from about 2012 as a part of total innovations. It increased earlier, but from 2012 it is decreasing. In other words, countries are not giving enough importance to green innovation, not putting enough money. So this is a problem, and we need to address that. And so for that, we need a lot more new innovations. Uh, so climate change is likely to have is going to have actually is going to have disproportionately large impact on the developing countries like India, and needs to increase our science and technology. Therefore, we need to increase our science and technology innovations to mitigate and adapt to these. And today, we are not investing enough money into in science and technology innovation. I think we need to increase the tenfold at least. But the government and the private sector both must contribute, must invest on this. Unfortunately, we don't have the private sector contributing much into this. So far, government has been contributing. The government contribution is also going down, but private sector is not coming up. So therefore, situation is not very good in the country itself. So. But the government labs themselves alone cannot achieve this goal, because they are also limited by the expert manpower and resources. But therefore, it is important that this that the university sector has to come into play, and that is why today, so far today, most of our innovations are coming from the about 100, 150 government labs. Very little is coming from the state universities and the private universities, and this is where our big gap is there, and that gap we have to improve. So our unless and until the innovations and science and technology innovations come from the university sector, state university and private university sector to complement the government sector work, then we are going to be unable to solve this problem. So to see in terms of our research and development status in the country, I think we are making progress, but not making as much progress as we should. For example, this is a report which was published by INSA last year, which talks about the number of science and technology publications. Science and technology innovation can be judged by the high quality publications in this field, and that measure, if you look at the China actually tops. This is the global total. This curve is the rest of India. This is China, and this is USA, and India is somewhere here. So last year, the China produced about 670,000 publications, whereas USA produced about 450,000, 450,000 publications, and India produced about 150,000 publications. So we are improving, but not improving. See, from 1996, if we see, we have improved, but not as at the rate as China is improving, for example, or and that is something that we have to catch up with. And our quality of the publications are also not as much as good as the others in terms of. So one way of measuring the quality is like how many of your publications are suppose you have published 1,000 papers, the country has published. Out of these 1,000 papers, how many of them have come into the top 1% cited papers? If I see that, and that measure is here, which shows that USA, every 1,000 papers, 1.9 papers come into the almost two papers are in the top 1%. And whereas European Union, it is about 1.3, China 1.2, we are somewhere in 1.9. So I think we have a lot of work to do in terms of getting ahead of these. I think we have potential, but I think we are certain, and I'm going to just trying to sort of highlight how we can fill up this gap, and or sort of go ahead of this. So it is in once you see. If you just look at how much of the publications that come from in USA, for example, how much publication total, out of the total publications, how much of it comes from the private sector, private universities, and how much comes from the government funded institutions. It turns out that in USA, in 2022, almost 70% of the top publications come from the private universities or private organizations, privately funded organizations. On the other hand, the government institutions contribute to only about 30%. That is also clear because top 10 universities in the top Ivy League universities are private universities in the US, and that is where for a lot of publications come from there. So on the other hand, if you see this situation in India, our thing is only about 90% comes from the government-funded institutions, and only 10% or less come from the private, and even less than 10% comes from. So this is it's highly different, highly reverse. And why this is happening is, I think, partly because there is a generic problem. I think we don't train enough science and technology. Sort of don't encourage even the country as a whole. So we don't even produce the basic people required for for going into the research. Basically, the graduates in science. So if you look at the total number of science graduates, graduates mean these are the undergraduates. You have not even done the postgraduate, let us say. So the science in China, for example, this is a very interesting report by Bharti and Yang. It is a very recent report, but where they have looked at the evolution of how from 1910 to today, how the universities system, the nature of the university education has changed. In China, for example, science and technology, the blue region is like where this is the humanities, law, and business, and this is education, science, technology, blah blah, all this top part. Okay, so in India, most of the time, our 70% of the graduates are in humanities, and science and technology only 30%. It used to be less, 20% there. Today it is about 30%. Okay, and the 70% is, so the students themselves, the graduates, we do our base of science and technology education itself is small compared to China. They have diversified that quite early, and they're today, they used to go up to about the humanities. Somewhere in the 60s, they had the science and technology were almost like 90%, and the humanities were only 10% or 20%, and it has changed over to this, but still now, so that created a whole base, and that was the growth of China's is because of this, because they trained at some point of time, they trained a lot of basic graduates in science and technology, which then went on to various different science. And so I think that is one serious problem in our country. It is already, it's so that is part of the problem. The other problem is this our university system. So if I look at the R&D coming from, so this is from a report from the higher education Ministry of Higher Education, where we have about 800 state and private universities together. Okay, and this private state public universities, state private universities, and deemed private universities. If you put together, it is more than 800 universities. Okay, and then our the national institution of prominence is about 150, central university another 50, so put together another 200 institutions. So these are central government funded institutions of research. So out of these 1,000 institutions, 200 are government funded and about 800 are public and funded. So, but most of the research comes from these 200 institutions, and in fact that is what our major problem is. So how can I bring from these 800 institutions are there, but the contribution to science and technology or even publication. First, let us start with the publication. How much publication come from that? It's a very small component. It's not even 10%. And that is what is our problem. And that is what we need to change. And this, I think this NEP should focus on that, and see how we can transform the state and government institutions into making contributions to the national, sort of coming closer and closer to the national institution of prominence, and that is the challenge. And so I looked at that in slightly okay. Before going to that, let me just mention how many PhDs we produce. So in totally, I think India produces every year about 68,000 PhDs, doctoral graduates, and sorry, 24,000 compared to about 68,000 by USA. We are ranked the number 4 in the world. Out of these 24,000, or out of these 68,000 USA, science and technology component is about 45,000. So it's quite large fraction is in the science and technology. Whereas in India, the out of these, less than 50% is in 11,000 is about 11,000 is in science and technology. So already our graduates, PhDs in science and technology are also small compared. Even the percentage wise, it is small. So uh, uh, but that is not uh, mm, a serious problem. I think that is not a serious problem, but I think this quality is the most important problem. Even though number is less, but I think if we had better quality, we could still overcome this situation. I argue that the quality and quantity of doctorate produced by our country determines the rate of the health of the research ecosystem. Uh, However, we know that students enrolled in doctoral programs at credible institutions where students need to carry out basic credible research is relatively low, and that is only about 20% or 15 to 20% of all those 200 institutions that I mentioned. Those are where at least some credible research is going on, but the rest of them, almost 800 institutions, there very little credible research is going on. So that is the major problem. So, see, what we need is we don't need to increase the number, even if we don't increase the number of PhDs, but if we can increase the quality of these PhDs that is coming out of many of the state universities, that will really transform our research and development output. And that is reflected because our this contribution from these institutions, from the state and public universities to the R&D is rather low, and that is reflected in this representation in the science academies as well, because that is, if you look at how many fellows of the Indian Academy of Science in Bangalore or INSA, if you see that, that is only about 10%. In fact, in the inside is less like 5%. Fellows are from private and state universities. In Academy of Science, Indian Academy of Science, that's about 19%. So this is still very low, and that is our issue. So therefore, I have been, what I'm saying is that we need to focus on improving these science and technology innovations or the research in the state and private universities. Private universities, maybe one or two universities do something, but the rest of them, vast majority of them, do nothing except giving the degree. Uh, and then, of course, they make money. So, how could the private and state university system contribute in accelerating? To do that, we must understand what is ailing these systems. So, unless we can change that, it will not happen. So, in my opinion, there are three problems that are seriously problematic with the state universities, especially state universities. I will not go into great details of the private universities because I don't have a very clear data on that. But one thing I know that the faculty recruitment is the most important thing. Suppose in the private university, in the state universities, faculty recruitment is not merit oriented. It is because of various different factors, influence, political influence, and so on and so forth. So as a result, what happens is that if the faculty is not good, then how can you expect the cutting edge research to be done? And that is, I think, is a major problem. Unless the faculty recruitment is revolutionized or reformed and UGC can control that in some ways, I suppose. If they don't do that, then this is a big problem. And the other problem is the poor science and technology infrastructure. Most of the state universities have no infrastructure, and there is no mechanism. The state government don't give them money, and as a result, they then how do you start a good research? Because in many of the the national institution where there's some good research is going on. Then a young faculty comes in with some ideas. They're giving some seed money to start a research, right? And then maybe start a small lab or buy an instrument or buy a computer so that you can at least start something, so that you publish some good papers, and then only you can think about getting a grant, better grant. So to that initial process itself is missing in the state universities. So therefore they cannot start doing anything. So, and the government might say that you get money from project, but how will they go? That they have to be given some seed money, and that is also not there. So there is no thinking about that, and I think that is what is we need. And of course, the most important thing, the research culture and the sort of the culture for excellence, or the environment of academic excellence is not there, and that is missing. And that environment and sort of there is a chalta hai type of attitude everywhere, and therefore you and that if it is that kind of a culture cannot cultivate important. That cannot contribute to the excellence in research. Uh, so okay. So how could this uh, so so what is the kind of what is this what I talk about today is a sort of academic environment, what is the vibrant academic environment that I talk about. So it's difficult to define, but you have to have an environment where the student and faculty should feel passionately about pursuing and doing hard work to pursue knowing the unknown, for example, and so that you have to have a sort of environment which will make you feel that okay, I'm happy to do this work. Uh, so and that excitement has to come through the environment, and like the labs and and science seminars, so uh, so you have to one of the things that can happen is of course if we can get excited by example somehow. If you can start this process in one department, for example, one faculty, one student created a very good study and then published in very high impact journals, that kind of an example can be then inspire others to do it. So but then so you need to create initial to do it, to create that initial thing. So you have to somebody has to help and give infrastructure, give some incentive so that somebody does good work and then creates an example. That example then has a positive impact on the others to pursue high impact work. And I think that is something that this is my experience that that kind of an example works. We also need to have the environment will also have the flexible time for the PhD student. You should have good campus facilities so that anytime students can interact with each other. I think interacting among students and rigid boundaries for is also very bad. And I feel that many of the state universities, the PhD guides have a very rigid boundaries. Students don't talk to each other, and that is detrimental. And this talking to each other often brings out new ideas, and then also get excited about work. And so that is why some facilities are also required, and these boundaries must be this culture has of that boundaries or compartmentalization must be removed. And some good facilities helps in sort of many times, even when I went to IITM first, it was working like a government institution, 9 to 5. My office was closed at 5 o'clock. So then what I do, I said that this cannot be done. This is not on a research institution, cannot have a 9 to 5 thing. Everything should be open anytime anybody can come. It should be able to. So I changed that. And this is the kind of thing we need. So I said that, okay, my office, I don't need an attendant to open my office. I'll take my key, I will open and I shall come whenever I want to come. So I think we have to do something like that. I feel that even my institution, Cotton University, I come on a Saturday and Sunday, I I have to ask somebody to open the building because you cannot enter. This is the kind of environment detrimental to for any research. So you need freedom to come and work anytime you want, and the environment should be supportive of that. And that is a part of this. So now this ecosystem has to be developed. Uh, uh, Also, many times I think this scientific seminars, regular seminars, and invitation of distinguished visitors from national and international visitors to come and deliver lectures are very other important inspiring things for the students to get excited about work, and that, of course, in most of the state universities are missing, and that is something that is also, I think, is important part of this. So. Uh, but today, where do you have, or what we have? What we have is that our students have are basically, uh, mm, uh, uh, most of the they think PhD is just like a degree. But I don't think PhD is a degree. If you want to do a PhD, you should not just think about a degree for getting a job. In fact, it will be a misconception that if you simply get a good PhD degree, you'll get a good job. You'll not get a good job if you simply get a degree. But the degree has to be worth it, and you should be confident about that work, research work. So most of the time, most of the PhDs, I feel, I have seen also a lot of them, and that is that they are not even understand what they have done during the PhD, because it was not that they wanted to really do research, but somehow they had to publish some papers and finish them. So this is not this is a waste of resources in their own human resources, I believe. So a PhD should be a degree for when at the end of it, the person should be independent researcher, and that means that he has to understand what he does, and in fact, in our country, most of the cases, I don't see that they are not independent researchers. Whereas if I see it in US or anywhere else in the West, their PhD means that that guy, that student, or that student, he or she is very independent thinking. They can do anything themselves. But today, even after PhD, if you ask somebody to start thinking about a problem, they can't think about it. That is because they have not been trained to solve the problem themselves, and they have not been trained to think independently. And I think that is also is something that is detrimental, and that we need to change. We faculty and students are generally happy to publish some few trivial papers and get a PhD, but that is a detrimental to any science and technology innovation. But many argument is one of the argument that state universities give is that, well, our papers don't get published because we do some regional relevant work, but it will not get published. It's difficult to publish. I think that is a poor argument, because if the science is strong, even locally important problems have, you have to relate it to a globally relevant science question, and there is opportunity for that. There is many. For example, the Northeast India is a biodiversity hotspot. The problems of biodiversity are universal, and therefore the whatever if you do here, and you can relate it to biodiversity in general and how climate change impacts on biodiversity in general, and that is, but that kind of work is not being done, and we are not addressing those important issues, and then so this will be very locally relevant, because biodiversity is very locally relevant, because the ecosystem services are directly related to the biodiversity, but that relevant research we are not taking up. We are happy to do something simple and publish somewhere, because those research maybe it will be difficult, and it will require some work, but we are not willing to put that. So this is what I have found, and this is a generic problem everywhere. So we are not willing to address the important science question that is need to be addressed, because it is hard, it is a little bit hard, and requires a little bit extra work. But we are willing to publish something very trivial, and publish a paper. And that is what is our basic problem. I feel that the desire for excellence is missing in. So we don't want to, sort of that. So something, the goal that if you do to do good research, I think we have to aim high, and that high aiming high is missing in most of these. So that is why we need to set some goals. So I think if we want to improve the system of the research and development in the university system, we have to we have to we have to set high aspirational goals for the faculty as well as the students, so that they will work for it, and then it's like getting INSA fellowship, Bhatnagar Prize, Infosys, etc. Fellow they also say aim high. We have to aim high. If we don't aim high, we will not achieve anything. So, and of course there will be challenges. Challenges have to be overcome. So first, to how do we do that? To do that is the first goal is to go from even from no impact factor journals to at least try to publish on high impact factor journals. So that transition itself is the first step. So that is I'll give an example of how this can be done, and how I was fortunate to do something like that in an institution. Um, so, but every impact paper published in high impact journals is in high impact making work. So we have to transform those papers to high impact making. That is the next goal, and that also that means that I'll talk about how we can I can go a little bit on that. So uh, 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 so one thing that we also seen that in the private publics in the sort of state universities, most of the students don't get fellowship, the PhD students. Now, I find it is a very strange, because the students who do not get fellowship, they have no real motivation to really work hard. They will only finish. So that motivation doesn't come. And therefore, because but the faculty wants to get some papers and then give it and have a PhD on his resume, and so therefore they will take and then make them work like slave, and then somehow publish few papers and finish. Neither the student they will learn anything, nor actually it will make any contribution to overall science and technology. And so these taking students because they want to get a degree. They said, I'll work without fellowship. I'll try to, but he wants a degree. He or she wants a degree. That is should not be more, in my opinion, promoted, because they really cannot. Those students cannot really do, or the faculty also will not do any serious work. So we need to create the state universities also must create a student only fellowships for these PhD students, and only motivated students should be selected through a rigorous interview process or selection process. So I think that is also a critical point. Unless you get good students coming into the R&D, you won't be able to do good work. So therefore, you have to screen the students. And how do you screen it? And unless you have some incentive for good students to come in, the good students will not come. The few good students will then go to the national university, institutions. So I think this is a catch-22 situation, and unless we improve that, that is also we have a serious problem. So how do, for example, this is an example of how we can sort of giving some incentive, we can change the quality of publications. So when I joined, this is a history of publication in the IITM Pune from 1971 to 23. So this is the red curve is the number of impact factor publications, and this is a total. The bars are total, and this is the period when I was there. So just before I joined, you see the number of publications were only about 25 impact factor publication, 25, 30, and there are about 50 total publications were there, 50 to 60 total publications are there. And that, so therefore, almost 50% or 60% of the publications were having no impact factor. These no impact factor journals I found are sort of almost like a predatory journals, and there are hardly any nobody looks at them because their review process is poor. There is no scrutiny. Anything gets published, so therefore it doesn't have any impact. So I said that, and then I looked at this, how the topics that they were addressing were relevant, but they were not putting enough work to make it the result robust, reproducible, and rigorous. And that is why it is not published in a good journal. So that requires a little bit of work. So I said that we will not count papers which have no impact factor on their review process. So in the promotional review and everything, it will not be counted. So, and then of course I provided some more infrastructure. Infrastructure was very poor, so I provided computers to the people and few other training. And of course, during that time, I also recruited more people. So the people were also aging, and the earlier recruitment process were at a very low level, and then the scientists grew from scientific assistant to scientist. They did not have the real aptitude for research. So they had the aptitude for helping others, but not research, really independent research. So therefore, the independent research number was very small. So I then recruited people at higher level, assistant professor level, and change the infrastructure somewhat. But this helped. You see, by the time towards the end, we increased the number of publications by a fourfold, and only about 5% of that was non-impact factor. Most of them were high impact factor. So the quality of impact factor increased from zero point 0.3 tenfold. The number increased by fourfold, but quality increased from 0.3 per paper to about 3 plus per paper at this time. So this is possible to do, but we need to help a little bit, gives incentive, and so that I think is very important, and it's doable, I think. Um, uh, So now let me talk about a little bit different topic, like really big impact. How do we make a big disruptive publication? So sometimes the research, what is a disruptive publication, for example, or disruptive impact making publication? Uh, so in general, a paper which is referred to, let us say, more than 1,000 times, is something that must have really created a difference in that field, because that might have changed the way the old concepts have given way to new concepts, and they changed the path of the growth of that particular area. Uh, mm, and that kind of a publication make a big impact, not only in terms of the innovative new ideas, but also in terms of applications in often. And that is why this kind of publications are often called disruptive publications. Now, how do I will give an example from my own field in a little while, but to how do you get into doing a disruptive publication or a big publication? So this requires looking at looking at the big picture. Many times many of our research basically concentrate on very small one particular aspect of some problem, and then get kind of bogged down into that details, and then don't see the big picture and don't connect it to the big picture. And if you don't connect your research to a big picture or a big science question or big, then it doesn't make a big impact. So to do that, but therefore one way of doing it is look at the science problem itself from an overarching as a part of an overarching science question, big science question. So think about a big science question, and then maybe your different components of that science questions are an integral part of a big science question, solve a big problem solving. So then, even if you publish several, 4 or 5 papers on a particular topic which is contributing to solving a bigger science problem, then that combination of those papers will make a big impact. And that is how you should look at the big picture, not just confine yourself. Whenever, even if you do some work, then you have to look at, okay, what is it? How is it relevant into the big picture? And that is missing in most of these. I think that is also is important in publication itself. Publishing in a very high impact journal requires connecting your work to a big picture. Without you connecting the context, the relevance, the importance of this work in the context of a big science question is what will help you publishing that. So you have to look at that. And this kind of a big picture today has become more and more competitive, so that because we have solved most of the simple problems, we have solved now the problems are more complicated. These problems to look at the big science questions are also more complicated, which requires expertise from different fields to solve a problem. Because now most of the important cutting edge problems are on the interface of different fields, and therefore those boundaries of the strict boundaries or the compartmentalization of physics, chemistry, biology itself has gone. And now, even within a field, there are these different sections. There are this compartmentalization cannot happen within each field itself. There are boundaries where the actually exciting work takes place. And to do that, to make those contributions, you need to collaborate. So without collaboration today, doing a very exciting work or very disruptive work is difficult. And that is why a collaboration must be a very important part of our R&D itself, in must train. So early, our faculty members, most of the universities used to be, or even today in many of these universities I know, are still very individualistic. They don't let their students to talk to the others or collaborate with others. But today, I allow my students to collaborate with others when they are doing PhD, because that is how they start learning about collaboration. And then when they go postdoc, they will then be much better in collaborating and doing bigger problems. So if you restrict them to just do your work and don't let them to talk to others and collaborate with others, uh, then the students' breadth also remains limited. In fact, I find that when you do collaborate, you learn new things. I myself do collaborate a lot, and then I every time I collaborate with somebody, I learn something new, and that new thing helps me to look at the problems different way in future, and therefore it is a win-win situation. So the students should also do that. I think we should train the students right from the PhD time to collaborate, and not just be sort of, and should not worry about the number of somehow some the we should not worry about the somebody else getting some what you call uh, uh, credit for publications during his PhD, because it doesn't hurt anybody. It only helps. Um, so but these high impact making publications must also stand the test of time. So that is where I'll come to that in a minute. But this is an example of one of those disruptive publication I mentioned. Fortunately, I was able to. This is one of my students' work, but he did it after his PhD. Just after PhD, during some of our discussions, some new ideas came, and during that, when we pursued it, it came out, and this happened to be a very interesting work. And because it became disruptive, because it changed the way we look at the role of Indian Ocean in the climate system. Until then, before this paper, Indian Ocean was people globally thought that, well, Indian Ocean doesn't have a very direct impact on the climate in the global regional as well as global climate, because it's kind of a passive to effect from the Pacific Ocean. But it turned out for the first time we showed that in this paper that the ocean, there is active ocean atmosphere interaction that can take place in this region, and that ocean atmosphere interaction can the oceans can modulate modify the atmospheric system. The atmospheric system can then modify again the oceanic systems, like sea surface temperature in the ocean. The sea surface temperature in the oceans can affect the clouds and the climate, clouds and heating in the atmosphere. This heating in the atmosphere can change the winds. Those winds can then again translate modify the ocean distribution, the temperature distribution, thereby change the heating distribution again. So this kind of a feedback in the ocean and atmosphere was not known before in the Indian Ocean region, monsoon region. And so for the first time when we saw that, it really opened up a lot of possibilities in terms of the influence of the Indian Ocean, and also the dynamically how it affects the atmosphere. So regionally as well as globally. So that is how this paper is cited so many times. So therefore, but this thing also is a part of a serendipitous work, but serendipity always does not lead to a disruptive work unless you can put it in the context of a bigger science. So this, in fact, we found out we are looking for something else, and then found out this possible ocean atmosphere interaction. We still was initially we were still going with the mindset that the Indian Ocean was passive and therefore no ocean atmosphere interaction. Then we found out that, well, there seems to be indigenous ocean atmosphere interaction. Then of course, then we did all the studies that is required to put it in the and demonstrate that this yes, it is an active ocean atmosphere interaction, and that is where, and then put in the context of global climate, and that is where what made it interesting. So these studies, impact making studies. How am I doing in time? Okay, we have okay. All right, I think we are okay. So these studies, the high impact making studies must at least somebody said, I learned this from some writing, that the most impact making studies and studies which stand the test of time must follow 3 R's. And those are the robustness, it must satisfy the robustness, rigorousness, and reproducibility. I think these are 3 big R's that any study uh, to to stand the test of time must satisfy. And these often we don't, when we write a paper, we don't do that. We should always check and then how robust is your a result. You find something, some result, some signal you have found, then you write up a paper. Then you think that it is important, then you try to send it to publish. But you have to ask yourself, how robust is this signal? Suppose I have used some data, and if is it the same signal comes from another set of data, or if I have used one technique of analysis, if I had taken a different technique of analysis, would I have got this? Should I have got the same signal or not? So all these things you need to verify and trust. So this robustness and rigorousness, and theoretically, so some observations, you have found some techniques. So can I support it by theoretical things? So the rigorousness to test that signal, the validity or the veracity of the signal, you have to test by techniques as well as theory, so that it is established as a rigorous, and of course reproducibility. Reproducibility is very important in biological and other science, is very important. Even in our science, like climate science, is important. But we normally use the same kind of data. Therefore, it is generally reproducible, but because our data is mostly global data, that is observed data. But sometimes some specific observations are collected. Those also must be tested for reproducibility. So, but also another thing that we don't do is self-criticism. We normally find a signal, and then you have to always ask, because sometimes we have our own bias, right? We feel so so engrossed in our work that we don't see it from a different viewpoint. That is why you have to ask that, okay, you have to ask yourself some devil's advocate questions, and those is kind of self-criticism and alternative hypothesis. So many times, many of these some results you have explained through a particular hypothesis. You have to ask, is there an alternative hypothesis that can also explain? That is important, because sometimes we might miss that, and that then your results will be questioned by others, and then later on, then it will not test of time. Then there will be controversies and so on. So alternative hypothesis testing is also important, and then either reject or accept those hypotheses. So, the importance of reproducibility is very important, and as a result, it's many times recently this retraction of papers have increased very seriously, and this is partly because of two things. One is, of course, the review process in the for example, this last year, this was big news. This Rangadayas, this guy at Rochester University who did some low pressure superconductivity at room temperature or close to room temperature. So this has become very famous, and then he had to retract a couple of his papers from Nature and other big journals. So these are big issues. But in fact, in last year was a bumper retraction. So most of these, about 10,000 papers globally has been retracted last year. So this is the number of retractions have been increasing, and this is from a report that I collected from Nature. And out of these retraction papers, where India also comes quite prominently, but the highest retractions are coming from Saudi Arabia. Can you believe why? Interesting. This is because I don't know there are how many institutions, scientific institutions are there, but then they have a lot of papers that I think this is coming because I think many of all these sort of open access journals have very poor quality review. Okay, and they simply pay money and then you get published there. And I think this is becoming a serious problem. So the open access journals, and as a result of the open access journal proliferating, and of course the number of scientists globally has increased. As a result, number of papers coming into the publishing, coming in for publication has also increased tremendously. But therefore, it is a problem. But that doesn't mean that we can compromise on quality of review. But the quality of review has become compromised today because of the number of journals that has proliferated. The number of journals, as a result, what has happened? Most of these, even prominent Nature group of journals and other journals also have proliferated many open access journals, and some of them are not really great, and that is because the review process is very poor. So they can't find really experts to really review, so they send it to some people who don't even understand the problems, and then somehow it gets through and they make money, but ultimately somebody will point out that there are serious issues. So this is a part of our the ongoing system. So therefore, that is something that we cannot help, but we have to be cautious about this. So that is why the questioning ourselves and looking at the robustness, rigorousness, and the reproducibility of the results by ourselves before publishing is very important, and that is it can guarantee you a impact making work. So as far as uh, citations is a measure of is somewhat a measure of how impactful the publication is, but not necessarily the citation has to be looked at. Generally, citation is simply by by citations, we cannot judge if the number of citations is relatively low, moderate. But sometimes today citations can be manipulated by self citations or by friends and sort of arrangements. But there is a limit to which this kind of manipulations can go. So therefore, papers who are really cited many times, like more than 500 times or 1,000 times, those are really impact-making publications. They cannot be manipulated by these systems. So therefore, often it is indicative of it is interesting to look at the top 100 publications of all time, hundreds top cited publications of 100 publications of all times. And if you do that, you see that the top three publications, top three most cited papers of all comes in some, is not by Nobel laureates or anybody, but they are all biological lab techniques. So many of the times, most cited papers are not on the real basic science, but on techniques, and that is something interesting. And in fact, even today, there is this. Today, I found recently that this is a paper on, and again, technique. The technique. This is on the neural network. This is deep learning AI, where this person of Indian origin is published in paper called Attention is All You Have. It is still an archive. It is not published in even journals, because many of the computer scientists don't even publish in real journals. They have the conference proceedings or in archive. But this archive paper has been cited more than 129,000 times in a question in a period of about 5 years. And this is going to be now almost fourth top cited paper in history of publishing, I think. And that is, this is not in those 100 papers I have seen recently. But this is something that is transforming because of the AI evolution. The last few, this is something called a vision transform. A vision transform is required to go find 3D pattern recognition. So the 3D neural networks require vision transform, and it is not available. And this is something that he has developed, and that is now making such a big difference in the AI applications all over the world, including application to the three-dimensional weather patterns, our weather patterns, and so recently this has been now applied to weather prediction. So now we have a deep learning AI model can predict weather prediction up to 10 days in ahead, as good as or better than the best of the physical models. Mm. And that has happened because of this kind of a technique, and that is an indication of that. Uh, uh, so in my field itself, there is the community is rather small. So the citation also depend on the how big is your community, how different people cited different people's work. So if the community is large, you have the potential for having higher citation. Our community is rather small, but it is changing because of climate change. Because of the IPCC, climate change has become so important globally, and it has implications on various different people and fields. And as a result, IPCC reports are very highly cited. So one of my article, which I am not a lead author, but I am a contributing author, even that is cited more than 2,000 times. So, so these papers are cited highly, and as a result, that is also growing our thing. In our field, there are actually two papers which has been cited quite a large number of times, and probably these are the highest cited papers in any geoscience in our of all times. And that is because, again, this first paper is related to not really any scientific issues, but it created for the first time it created a set of observational data analysis starting for more than 40 years at a regular regular points. See observations and which are consistent with the equations of motions and and that kind of observations, because basically we have observations from different irregular points at irregular time, they are not at regular grid points. They are not available at regular grid point. But for making weather prediction or climate prediction, you need observations at regular grid points. How do you do that? You take the observations and analyze them into regular grid points. But when you do that, observations have their own errors. So those observations are not balanced with the equations of motion and the energy equation. So then what do you do? Then you use the model itself, the physical model, to correct this, and they sort of minimize the error between a global constraint, and that is called data assimilation. So you do data assimilation and do analysis of the data into regular grid. So that regular grid then actually provides a balanced global observing data, and that kind of a data and consistent data over a period of time, which can then allow you to study different processes in the atmosphere as well as the variability, which earlier we could not do because the data itself had a lot of errors and those consistent data was not available. So that made a big difference. And so once that was available first time in 2001, this paper is now cited more than 34,000 times. That is, then there is of course another basic fundamental paper on science by Ed Lawrence. This is a paper where he discovered what is called now well known as the deterministic chaos. The word chaos is now applied in many fields. Almost all of you probably know about it. And it was Ed Lawrence, who was a meteorologist at that time at MIT. He discovered this idea from a very simple set of equations, and then he visualized how it is applied to the atmosphere and determinist and that has really opened up a whole new field on the chaos, and how chaos in the atmosphere, deterministic chaos, is responsible for limiting the predictability of weather systems and climate systems. So this is a very fundamental paper, but that also is because of its nature of it opened up a very new field, and it is cited more than 27,000 times. So these are the kind of things that can make a big difference. Let me see how much time we have. Okay. Uh, uh, so I think I'll not go into great detail. So I think then I'll conclude. So we need to. So my role model in impact making publication is Professor Sienna Rao. He was the director when I joined IISc, and he is one a prolific publisher. But at the same time, his work is also very highly impact making. For example, he has highest by his total citations are like 1,19,000 times, 19,900, 20,000. Highest citation is 4,600. On the other hand, he has more than 10 papers which are cited more than 1,000 times. So I think he was like any of those. So these are the last 2021, the Nobel Prize of Physics was awarded to two climate scientists, Suki Manabe and Klaus Hasselmann, together with Giorgio Parisi, who is a physicist. So all these three people worked on complexity and climate change issues, and all of them had a lot of, say, for example, Manabe had 15 papers more than cited for 1,000 times. Parisi had more than 10 papers, more than 1,000. 10 papers cited more than 1,000 times, one paper more than 10,000 times, and so on. So these are also very highly people who have published more. At the same time, they have published also very impact-making publications, and that is why they are. What we need is you have to think big, and at the same time, you have to have a think long-term vision. The long-term vision, I don't want to go into details because it will probably take a little bit of time. So let me skip that. And uh, so let me talk a little bit about this. As I mentioned already, that this in fact the disruptive publications are often serendipitous, but the but serendipitous cannot really make all the, sort of disruptive unless you put in the real effort. That effort has to be put in terms of establishing its robustness, work on theory and mechanism, and maybe connect it to the big picture and potential applications. So our this paper, the IOD paper, is an example like that. But this to find this serendipitous discoveries do not come if you just sit on something. It comes only if you keep on working on something, working on problems, and that is an example that has been seen from history of publications of some people. So someone looked at 1.5 million scientists. Out of about 1.5 million scientists, about 150,000, about 1% of them published without missing a year. So there are people who have missed 1 or 2 years, and then all of them publish about 300 to 400 publications. But now you see people who did not miss a year, how many of impact making publications they made, and how many of those people who missed the 2 or 3 years in between, or 1 or 2 years in between, what is their contribution to impact making public? It turns out that this 1% made constituted 47% of all papers, and 87% of papers cited more than 1,000 times. So only those people who are continuously publishing, they come up with ideas while working continuously. They come up with ideas in between, and about something interesting, and that something interesting becomes a impact making publication. So it is very important that you cannot sit and say that tomorrow I'll find a very impact making publication. And the whole idea of that, only people who publish few and few good papers, they don't make impact, because some are very good papers, but they don't make impact because they could not get into. Some of my good friends were very conservative in publishing, but so the publishing at a regular rate is important to get those impact making publications also. So you cannot wait that, okay, I'll find one day something very good and that will publish. It will not happen unless you keep on doing, because while doing this continuously different type of work, so keeping a stream of publication is important, and you have to keep looking for those new ideas that can come. And I think this is also important part of our strategy, how to. So in conclusion, so what we can I have basically said that high impact publications, talked about high impact publications by through increasing the number of high quality PhDs and the postdocs, by improving the research culture and the research focus, and the and environment for academic excellence. So these are the things that we to need to do in the university, in the universities, especially the state universities, to be able to make high impact making publications. However, this state university, there is a dichotomy here. There is a contradiction and a problem, and that is state universities and private universities. This is unlikely to happen, because unless we make serious reforms in the faculty recruitment and science and technology infrastructure funding. These are two key areas where, unless we do something very important, I will not be. So my suggestion is that you should see, today there is a culture in many of the states just convert this state in colleges into universities, left, right, and center. In Assam, I am seeing that. This is terrible. is killing the whole. Neither the state government is putting any money for infrastructure or hiring any new faculty, talented faculty into the system, but simply for the namesake and sort of satisfying some public, they make convert. A large number of universities has been converted into colleges have been converted into universities, but not given any extra money or anything. So what is the gain? It is just killing the system. So this is something must be stopped. UGC must stop this. They should not simply grant these state university unless a certain some of these criterions are fulfilled. So uh, we need much larger number of high quality PhDs and postdocs. So the postdoc is another problem in our country. See, the most of the institutions, even the best of the institutions, don't get to keep the postdocs or get new postdocs into their projects. And that is because most of the time the good PhD students tend to go out for do postdoc, get exposure. Now, state universities, though, the question doesn't even arise. Now, but postdocs is where they see most of the time our state universities or even the best of the universities. I was at ISC, even then the students, especially in climate change, the students that we get are not ready to do research, and we need to train them almost 2 to 3 years before they can really start to do research. So therefore, the student contribution to R&D doesn't start from day one. It starts very late, and by the time they end, they make some contribution, then they go away. So it is. So in US and other European countries, the postdocs make the biggest contribution to the actual R&D. So every group should have good postdoc because they are already ready to do research. They can do independently. They don't need that much of intervention because most of our PhD students need lot of coaching, lot of intervention. They are not ready to start think independently. So, but postdocs can think independently at least if you can hire postdoc. But at environment is not there. Even in ISC, it is not very little. In most of the institutions, very little, very few postdocs come. But look at the Stanford on each all these professors have 5 to 10 postdocs working with them, and that is what drives their work. They don't have to do actually get into nitty gritty. So they can postdocs will do all the work because basic work because they can only give some broad ideas. So this is the kind of thing that can accelerate and that is messing even our whole country, and we need to encourage that and in a quality postdoc induct into more of quality to the institutions, and especially in state institutions. Uh, uh, Private sectors. So I think so. The problem is that today the private sector contribution is almost zero. I must say almost zero, if not zero. But the government is cutting down. The government policy has changed, and the government is cutting down government contribution. And now we have NRF. Now NRF says that okay, 30% only will government will give, then 70% you generate from connection with private sector. But where is the culture? Private sector in this country has no culture of investing in the basic research, and without basic research, innovation will not come. Innovations will not come. So, and there is private sector. There are all our private sectors are all the corporates are very myopic in their view. They don't want to invest any money. They want to get money back, but they don't want to invest any money on R&D. So there is no job for PhDs. How many PhDs our private sector companies absorb? They don't. In US, there is so much of, for example, job for PhDs going into private sector. That opportunity is also not there in our country. So the private sector has no culture of nurturing basic research, and then suddenly you cannot go from 0 to 70%. That means that I think this policy, government policy, is actually going to kill whatever little research that we are going to have. So this is a serious issue. How do you do that? We can start doing something by public private partnership, but then the research will be very much limited to what they want, and that will be very short term goal and no long term vision, and as a result the basic research will also affect will be actually the countries, whatever progress we made over the last 50 years in terms of basic research, that will also go down. So we have a serious problem in our hand, and I think very drastic measures are required to change this and improve whatever I'm envisioning. I'm dreaming that the private public state universities should contribute. That's very unlikely to happen unless we really change some of these impediments. That in fact we are creating more impediments into this, going into the NEP. Um, uh, we are creating even more impediment for progressing in that direction. So with that, I'll stop. And this is my department. In front of my department, this is a small group I work with. And with that, I'll stop. Thank you. Prakash, how am I doing in time?
Oh, you're good. Thanks a lot, Professor Goswami. That was a wonderful presentation. And it was nice to get a very broad overview of this current state of research and development in the country, but also go into details of one of the important aspects or metrics of measuring research and development, which is publications, and
Uh,
take a deep dive into it. So I'll request the participants to unmute themselves and ask the questions if you have. There are a couple of questions in the chat already, which I can read
okay,
out too if the
okay,
participants cannot
okay.
unmute themselves. Okay, so the first question is by Professor Kulkarni. In last few years, the cost of publishing research in high impact journals has significantly increased, leading to a rise in paid publications. This trend has posed challenges for researchers, especially those who lack sufficient funding, especially from colleges. What measures you can suggest to address these financial barriers and ensure equitable opportunities for researchers to publish their work?
Yes,
He's
I think
from St. Xavier's College in Mumbai.
Oh, okay, okay.
Mm.
I think this is a very valid question and very good question. But yes, well, I am from the Cotton University, where there is no infrastructure, no money, and for the last 6 years, I am facing the exactly same problem that you are facing. So it is a very serious problem today because of this open access, sort of. Open access culture of publishing, that everywhere you have to pay. Even these societies, which many of the societies who used to promote the boat, is now restricting. For example, the American Meteorological Society is now, without any exception, they demand base charges and so on. So it is becoming difficult, and so that is one aspect. So, but there are still, we have to try and see the way practically what I do is we look for wherever that is possible. There are some still good journals, society journals, which are reasonably good, and so we try to publish over there. So basically, so even though that may not be in terms of impact factor, it may not be very good, very high, but in terms of quality, they are quite high. For example, I can give a example of Quarterly Journal of Royal Meteorological Society. This is a good journal. Its impact factor is not very high, maybe 4 or 5, but it's a very quality journal. The review process is good. So I prefer publishing today. And in very high impact journals, it is becoming also very difficult in publishing because of the nature of reviewing processes today. And in science, nature, and everything, in old days, I found that their editorial process was very knowledgeable. The editors were good; they could figure out, and they could find good reviewers. But today, even in nature and science, I don't see they get the good reviewers, because the I see. And the screening process is ridiculous, because their editorial, if you see the editorial board members, have no real experience in research, and then have no breadth in their knowledge. So they are very narrow, little bit. They have published only few papers, and they're very young, and and they will decide what is the importance of your paper, and therefore they screen it out. And this has become a big problem, because some of these big journals, like in Western science, will allow some fraction to be published in without cost of. But then you are getting through there has become a very difficult, and that is. But we have to keep trying. That is something that I keep trying, but I don't bank on it. So I publish on the on good good what you call what they call the subject journals, not really general journals, broad journals. So, so that's one thing that you have to do. But you have to have a little bit of an option here. So therefore, uh, uh, mm, mm, uh, uh, also publishing wise, there is other thing that is happening in the publishing business, is that especially big high impact public journals like Science and Nature, there is a bit of a coterie system now. There are few people who are control this now, and they have their own cronies and friends, and so if you make them as a co-author, then your paper will get published. But otherwise, if you don't, then it will be rejected in the in the screening process. This kind of things are non-scientific things are going on, but unfortunately, you have to live with it. But I think you have to live in the area of open access journals. Now, open access journals are going to be the norm, but therefore we need to at least our government to this the funding, like in US and all, the projects have a designated money for. There is a head for publishing, and that for that money is earmarked. So the projects will earmark money for this publication. I think our projects also have to do that, unless the government helps us doing it help in other ways. But the government is talking about subscribing to, because they don't want to. Uh, I have been hearing about subscribing to a whole lot of journals where you don't have to. The government will pay, and then you don't have to subscribe, sort of pay charge and stuff like that. So this is something that needs to be done, because it is an impediment in terms of publishing. Sometimes it is a struggle. Um, uh, Many of the journals do, like American Geophysical Union, they allow exception by waiver. So we always try waiver, and if it doesn't work, then uh, obviously I from cotton I cannot never pay. There is no money. So therefore, if I don't get waiver, I go to another journal and I try. And there are few options. Options get limited, but you have to try there. That is all you can do. So ultimately, I think the government and must the funding agencies must have a system by which at least a certain amount of publications should be supported by the system, and then you have a little bit of liberty to explore good publications. So I think this is a problem. A debate is good debate is required, and the government should take some DST and SCRB. There are some debate, but it never got any conclusion to my knowledge. But then, mm, but this, but I'm not sure if the government will be the NRF will be very supportive of this. So, so if you do sort of the research which is associated with, the sort of research which in collaboration with private enterprises, then of course then you can demand that there should be a publication charge in these the publications or something like that. So something, all these things we have to explore, because I think from time on, slowly many of the research are going to be, sort of funded partially or wholly by private organization. Otherwise, research doing research itself will be difficult now. But that is not something that I look forward to. But this is going to happen.
Seems like it. Yeah. Professor Maitai, do you want to unmute yourself and ask a question?
Thank you, sir.
Yeah.
Good evening, sir. Thank you, sir.
Yes, go ahead.
For your eye-opening suggestions and ideas on improving the quality of our research papers. And sir, I have a query regarding the impact factor and quality of some journals. Basically, I work in astronomy and astrophysics, and there are some journals which are traditionally very, very reputed journals, like IGMPD and IGMPA, and which are now not having very good impact factors. But they are, though they are very good journals. And on the other hand, there are some journals like the Chinese Physics of Journal, Chinese Journal of Physics, very good impact factors. So there is a dilemma to give priority between these two types of journals. One having very traditionally very high repute, and another having very high impact factor at present.
Yeah, I think there is no brainer. To me, it is a no brainer. Don't go for this high impact factor from these newly started. Go for the old reputed journal with low impact factor. Doesn't matter. Your work will be recognized. That impact factor. See, when I sit in a committee to evaluate, I don't really go only by the impact factor of the journal. I also go look at what is his reputation. So it is not just the impact factor. I think you see, for example, there are many very, very, very good journals, and also it depends on the field. For example, in mathematics, it will be very low impact factor, but also even fluid mechanics. The Journal of Fluid Mechanics JFM is a very reputed journal. Its impact factor is just 2.5 or something. Okay, but those papers published in Journal of nobody. We don't look at the impact factor. If you have some 3 papers in Journal of JFM in fluid mechanics, it is great. I don't care whether it is the impact factor is 2.5 or not. So people, the experts will not worry about your. I think you should never work on only those very high impact, like few very high impact journals are keeping their reputation. Except for that, most of the so-called high impact journals today are not reputed. Their impact factor even is 10 or something, 12. Sometimes it doesn't matter. This is not as good as your 2.5 impact factor in a very reputed society journal.
Okay, thank you, sir.
Yeah, I think there's a question in the chat again. This is from Professor Rajagopalan from St. Xavier's, Mumbai. I appreciate the concept of research projects at the UG level, but for colleges where student strength is high at UG level, group projects are feasible, where a group of 4 or 5 students can work together on a project due to limited resources and infrastructure. Also, the time that they are able to dedicate to this is less, as this is not part of the credit system currently. Though this may change eventually with NAP. In such a scenario of short span of time, limited resources, what is the ideal expected outcome from these projects? This insight will help faculty members like us who are at the start of their academic career.
Okay. That's also a good question, but I think it is from practically. I think to start with, if you cannot do individual projects, of course you do group projects. The idea is to excite the students. It is not that those students, those short small projects do not result in a great publication or result in publication or something. But I think the idea of those short projects are to excite the students. The excitement of the students can come in individually if you do, or even in a group. That will, so what you have to do is get them involved in the research that you are doing, and communicate to them what is the excitement in that research, what is the new, why you are doing. And that is if you can communicate that, and then they get excited. So even in the group, that is fine. It is not so. And then you give them some group activity so that they start thinking about that by themselves. So something creative, let them do something creative. I think what is missing in our system is not making the student ask questions. So unless we ask questions, unless the student asks questions, they cannot really think independently, and no innovation can come. In fact, I think our biggest problem in our whole system, education system in the past and even today, is that it's partly our cultural distinct heritage, like Guru Sishya Parampara. Guru means the teacher, whatever he says, you cannot be questioned. And that, unfortunately, is in our old days, the rishis did not follow it literally. But today, many may be following it literally, so that they don't because many of our teachers are not very competitive, and therefore they don't, maybe lacking their knowledge, and so they don't ask, don't like asking questions, so they don't encourage. And that lack of encouragement to asking question is the impediment. And they then can start asking questions, unless you keep asking why this is happening, why not that, why this is happens, and why not it did not happen this way. This kind of question is what is going to bring it your innovation. And that learning, that process, if we don't start from the student, it will not cultivate in the end, properly at the end. And that is why we cannot do a good PhD. So, and that is the question. Also, we have to cultivate in the students, and that is what it will happen. Even in the group, it will happen. If you only think that you have to invest some time in creating their inquisitiveness and making them ask questions. So that is what is required. So I think these projects can still work in groups, but this innovation, I mean, I think ultimately, if a good PhD has to be independent, and that he must start asking questions. And I have found many PhDs in this coming out of the state university. They do something in their PhDs, and then when I ask, why did you do this? They have no answer, because there's a guide asked them to do something. They did, but I said, why? What is the relevance of this work? They have no question, no answer, because they have never even asked that question. So a PhD student must always ask the question. If the guide gives you a problem, they must ask, why am I doing this? What is what I'm expected to get out of this is how it will affect the science or applications. So you have to ask that question, and none of the students ask it. And this is a big problem. And so we have to change that. NAP will not work unless we change that. This all this NAP will remain paperwork. Mm,
On the topic of undergraduate research, I personally feel that in principle, one doesn't always have to go for new projects too. There are a lot
right.
of
You don't have to
old
go to
stuff you
no, you
could
don't have to
do
go.
things,
No. I think my
and
idea
you
is
can, you can view things in a very different way with the current state of science, and you can learn a lot. But that inquisitiveness you're talking about, asking the questions in existing research,
correct.
that can
Correct.
lead to a lot of new
Also, it
things.
broadens their base,
Mm.
broadens their outlook. See,
Yeah.
I think this is something that I think our the students who have a high aim, they start thinking today. Not most of it. So we need to encourage the others to also think. For example, I'll I spent 3 years in after my retirement. I spent 3 years in ISER Pune. Okay. And during that time, many undergraduate students worked as 2 months, 3 months, as intern with me. And I found that some of them are very inquisitive by themselves, and they really do every summer or every winter, wherever they get a break, they will do a project somewhere or the other. And the one of the student actually was very bright student, very young bright student, in the third or fourth semester comes, and then I gave her a very small work on predictability using Lorentz equations, and she did fatafat, and then understood, and then she came out with these are some bright students can really get excited, and then she made an excellent presentation after 2 months. And then she learned about this predictability and then fluid mechanics and all these issues. Then she went in another. Later on, I found her. She went and did another project in another subject. So she learned technique something here. She learned another technique somewhere there, and then also got exposed. And then by the end of her masters, she was ready to do anything. And today we don't get that kind of a student to do come for PhD, because then I still have to spend 3 years to train them to do the methodology. But those students who do these projects will get exposed and learn the techniques, so that by the time they finish the master's project, they are ready to do anything. And they are almost able to independently. That is what we have to build.
So there's, I think, just a comment from Dr. Charu Mehta. Since there are a lot of challenges in research publication, why not weightage is given into review? Why not weightage is given to review papers?
See, the review culture, review paper culture I have seen. Unfortunately, the review paper is good if you do a proper review, but if you simply collect data from here and there and put together a narrative, it doesn't make a review. So unless the review has to be impact making, then that means then you have to do synthesis. So you have done it area, then you do whatever is people different arguments. Maybe there are different people have given different alternative hypotheses, but there then you have to give a synthesis of what has been done and what is lacking, what is the gap area. So if you can do that kind of a review, it is still useful, and then it will be published in a good journal. But many of the reviews that come from the state university, I have seen many people, they write reviews as a part of publication, but those publication reviews are not very worth it, because they don't do a good job. Because unless it is done, a synthesis is done, some sort of a good, you have to ask questions. It's a review doing. So you have this n number of papers, this and that, so on. So and so did this, so and so did this, so and so that kind of a narrative, it doesn't make any big difference, because that everybody can collect. So, but if you do that, okay, so and so said this and so said this, but this difference is because of this, and whether this difference resolves a problem or creates a problem, you have to sort of analyze that in a way, in a critical way. And that if you can do that and do some sort of a synthesis of emerging knowledge from that, and what is still gap areas and what is the future, that kind of a thing, if you can do, that will still be a good review. So it is the quality of the review that will matter. It is not just the review. I have seen many reviews, unfortunately, not very good, because they are not worth it. They will not be published in any good journals. And then you can publish in some journals, but then it will not be worth it.
Yeah, that's true. Thanks a lot. Thanks everyone for
Thank you.
joining,
Thank
and
you very
thanks a
much.
lot, Professor Goswami, for taking the
Okay.
time this evening
Okay.
and
It's
giving a
my
wonderful
pleasure.
talk.
Pleasure.